Welcome to part 6 of Competency 10. In this video, we will answer questions relating to mean value and concavity. Number 1, determine the value of C in the open interval 1 to 6, for which G prime of C equals the average rate of change for G of X equals negative 3 to the third plus 4 over this open interval of 1 to 6. Okay, here's the thing. This is in regards to this type of question. This screams mean value theorem. Well, what's really happening with the mean value theorem? What you need to do is get the slope of the interval. And what it is saying is that one of the answers that you get will guarantee that at least one of them, the positive or the negative, will be in between those intervals. And you need to use your calculator, the graph of it, to double check which one will be in that zone, that area. Okay? All right, so this is what we need to do. First, we need the slope of what's given. Well, let me show you what we're actually doing here. So I'm going to draw a line. So we need the slope, and that is equal to, okay? So we know that's the change of y over the change of x. The change of x is 6 minus 1. Okay, now how do we get the change of y? Don't calculate all that. Go to your calculator. Let's go to my y equals. Go to your y equals. Now I've got all kinds of junk in here. Okay. I'm not going to clear out all my stuff. Okay. Because we will use it later. But for right now, well, let me see. What am I using right now? Okay. Well, it doesn't hurt me to type some things in, but I'm going to like recycle my first one here. You see what I'm doing? And I'm going to delete out this, all the things after. Notice I have to keep arrowing over, and it's up to you. You could clear everything out, go with a clean slate, but this is an opportunity for me to show you how to do this. Okay, now notice I've entered in the equation our g of x, exactly what we want. Negative x to the third plus the 4. We're good to go. Now, the thing is, so if we go down below that, we need to, I ordered, okay, arrow over to where your cursor is on the highlighted equal. Push enter to deselect it. And then I'm going down here to the bottom to deselect the other items I have in here. And I may clear out some of these things in a moment, but regardless, doesn't matter. Now, as you see, the only thing selected is my y sub 1, okay? My first uh, line. Okay, now let's push graph. And as you notice, it's the only thing that shows up. Now, let's look at our table. Second graph to get our table, and there's our table. Now, it looks like it's set up in values of 1/3 increments, which is okay. We use that for a prior video, but it doesn't matter. We need that now because I'm wondering from what I see if I need it in that. We'll see in a minute. What we need to know right now is we need to go to the value of 6. Okay, I'm not going to arrow up and down. That may take a while. So let's go second window. And where it's my cursor is, I'm going to say 6. Enter to make sure it goes in. And yes, our table is set up in increments of 1/3. So now I'm going to say second graph to go back to my table, and I'm at number 6. So that is negative 212. Now I need to subtract the value of 1. So now I will go back again and just push number 1, push enter. Oh, I don't know. That's a habit of mine. second graph. Okay, and that is 3. Okay, so when we put this in the, I'm going to put this in the calculator as is. That's what I'm going to do. Okay, and we should get a good value. Okay, so second mode. I'm not taking any chances, but I'm going to use my parentheses because we're mixing subtraction and division here. That's a order of operations nightmare. To solve that, give yourself peace of mind. Just quickly use your parentheses. See what I'm doing? And then minus the 3 parentheses divide. Open it back up. And 6 minus 1. I'm not even doing this simple math. I'm just putting in what I know needs to be done. And push enter. Okay, we have a... Oh, look at what I did. Did you see that? I pushed the wrong thing. Well, it's not a big deal. All you got to do when you see your silly mistake... Okay, I see what it did. Okay, so I'm deleting that out and pushing an actual subtraction. I'm not, I think I may have made that mistake. Okay, while I was yakking. There's our value. Always double check what you enter. Lesson learned here. Minus 43. Now that's how I get our M value, our slope. Okay, so now what do? What we need to do is use the first derivative, set it equal to our slope, and then we solve for what we call C. Okay, we're really not solving for X, we're solving for a related point C. Now, if you need more information about the mean value and the mean value theorem, like I've said several times at the end of my videos, there is a resource, a YouTube channel that is fabulous. I refer to that myself even for some of the upper level mathematics. It works fabulous. This particular channel has everything you need, very reliable. Okay. All right. Now let's do this. We need G prime of X. And this equals minus 3x squared. Now, what we need is the C, okay? All right. Yes, I'm doing this a bit formally, okay? So we set that equal to, I'm going to bring it over here, minus C squared equals the negative 43. Okay, see what I'm doing? Now we divide both sides by that minus 3. This cancels. And we know to get a value for our C, okay, we just pop that under the square root. The square root, the radical. Okay, but we have a negative divided by negative, so that actually cancels out. So we know that here. I wonder why that was going to miss. Okay, we know that we have 43 divided by 3. Now remember, that's positive or negative. Now our A, B, C, D options are trying to trip us up. Okay? All right. We know A and B won't work. Now we're stuck on C and D. So let's go look at our graph. Okay. Well, the honest truth is that we are only using the interval of 1 and 6. And 1 and 6 are positive, that 1 to 6. So we have 1 to 6. So this means our negative situation of the square root here. Let me show you where that is. That will actually, what will happen is our negative x value on this other side will not be included because we're on the right side of your y-axis. So the truth is the option we select in this case is D because of where our intervals are. Now, if our interval had been from -6 to 6, then that's totally different and we would have another conundrum, okay? All right, but right now we're okay. Option D is selected and our negative is not valid because of our interval. Okay, let's go to number 2. All right, determine the value of C in the open interval of 2, 2.1 for f prime of C equal for which f prime of C equals the average rate of change for f of x equals 2x squared plus 5 over the closed interval of 2 to 2.1. Okay, we already know the value of m in this situation. Okay, and this is a little different, so we don't have a positive negative thing. I'll go ahead and write out our value. We've done this in a prior video. Okay, so we have m equals, okay, and that is uh, 2.1 minus 2 is 1.1, okay, obviously, okay. And then we have 13.82 minus the 13. Okay. Someday I'll get better at writing with this pen. Okay. So then we know we have a 0.82 over the 0.1, and that gives us 8.2. Okay, which we did in a prior video. All right. So now our y prime equals 4x. That's it. That's all we have for that is 4x. Real simple. So if we put that equal to, well, let's make it c first, okay? So then we know we have 4c equals 8.2. Set it equal to the slope. Divide by 4 on both sides, okay? Cancel that out. What's going to happen? Well, let's just put that into our calculator real quick and we know what that is. All right. Second mode, and we have 8.2 divided by 4, and option B, 2.05. Okay. All right. So in this case, we didn't have to worry about negatives. Everything was positive. So we could have immediately gotten rid of C and D. Okay. All right. Now let's go to number 3. Okay. I can see 3 being another situation of positive negative, but it looks like they've solved it for us by only giving us positive values as options, okay? All right, so 2 things need to happen here. We need our slope, and then we need to deal with our y prime, okay? Okay, let's do this. Straight line, and we know we need the slope, and this will equal, well, this is a little different. We start with the greater value of 3, subtract the -3, and then we need to go back to our y equals. Let's see. Let's go ahead and put it in the first one, okay? We'll clear that out and put in 2x, square that. Oh, no, we're not squaring it. Well, that's not a big deal. Put the 3 in, okay, to the third, arrow back over, plus 1, okay. Now push graph, okay, and that's the correct graph, exactly. Okay, now we need second graph to go to our table. We need the values of 3 and -3. Well, this is what I'm going to do. I'm going to go to second window, and I already have it set for 1 to be at 1. Well, I want to go to 3, and then I'm taking off the 1/3. we needed it for number one, really, so I left it. But now we need increments, single increments, one. Okay, so let's go second graph. Okay, now that gives us 3. I can arrow up a little bit and capture. See, now we see -3 and 3. Much better. Okay, so what does this give us? This gives us 55 minus, and then go to -3. That's a -53. So minus a -53. Okay, again, let's just put that in the calculator real quick, and this will give us our M value, our slope. Okay, so second mode, and remember, use your parentheses or we'll have a real serious issue. Okay, so that's 5, subtract. Okay, oh, that's what happened before. I'm using double parentheses. I really, well, or we could do this. No, I'm not going to. You could say a negative times a negative is a positive. Well, let's do it this way and see what happens. Minus 53 and another parentheses. Remember, you have to close all your parentheses and then divide and more parentheses. 3 minus parentheses minus 3. Close it again. Push enter. And that's correct. Okay. See what I really had to do? I mean, it wasn't necessary for the prior values, but it is for this one. Okay. So very good. So just use all your parentheses to close everything in and we're good to go. All right. Now we need our y prime, our first derivative. So take your first derivative. I'll say y prime equals 6x squared. Okay. Now we need to put in our c. Okay. So we have 6c squared equals the 18. Now we divide both sides by 6. Okay. Right. And we know that to pull that out of, pull our c squared out, we need to take the square root of both sides. And the truth is, you can already see what that's going to be, right? But don't forget, we have a positive negative situation, okay? And that will be positive negative the square root of 3. You can put that in your calculator when the numbers get ridiculous, like if we're not sure what that's going to be, okay? But we know we're still under the square root, so it's not necessary to get a decimal. And we also know by looking at our ABCD options. Okay. And if you're not sure about the division, you can just quickly say 18 divided by 6. Well, that's 3. Okay. So we're good. But we know we're doing the plus. Okay. We're not using the minus because they simply didn't allow it in the options. Okay. All right. Let's move on to number 4. Number 4, given f of x equals x to the third minus 2x squared plus 5, on which interval or intervals is f of x concave downward? Okay, concavity is second derivative, okay, and also points of inflection. So what do we need to do here? First thing we need to do is look at the actual graph of our function. So go here. I am actually on the first one. I'm just going to clear it out. Okay, but as you notice, I have that here in our second one. Okay, so I'm going to see how my cursor is going on the equal, push enter, and it turns it on. And notice all my other items are still turned off. Okay, so let's push graph. There it is. Great. Now we need to figure out, we need concave down. Well, looks like that is from negative infinity to some inflection point. Okay. It's going from the negative side, and our function continues without bound. So that being said, option A and option D are out. And the reason option D is, even though it's negative, is that saying that that's an inflection point. So it stops or turns or the curve changes. And that's just not true. So now we have two other options, okay? And they're reciprocals of each other. So somewhere over here in that positive region, I can see on my own right now from our graph. If you look at the graph and you look at these answer choices, I'll move that over a little. These answer choices, I'll be honest, you see that our line crosses and kind of changes after one, between one and two. I'm thinking our inflection point is between one and two. And that would be option C here. Now, option B is showing a negative situation. Uh, well, what they're trying to say is, well, that may be on the other side over here, but that's not what our graph is showing. It simply isn't showing. Now, if they had taken the negative off, which is more likely to happen, then those options would have been pretty close, but our graph would still say that B is wrong when you look at the graph. Well, we're going to go through the motions here because let's say it was a type of graph that was so close you couldn't tell the difference, okay? All right, so this is what we need. We need to get y prime, okay? And that's 3x squared minus 8x, okay? Set that equal to 0, all right? We're looking for our point of inflection, okay? Oh, no, that's not 8. Yes, it is. Oh, now we need the second. Remember, concavity is related to the second derivative. So now we have 6x minus the 8 equals the 0. This gives us 6x equals 8. Divide both sides by 6. And then x will simplify to 4 over 3. Okay? Now, here's the thing. Another thing we need to do is find the point of inflection, right? We'll use the point of inflection, and then we know because I have the value of x, I know at least what the x value of that is, okay? All right, so let's do something here. You see how my x is in it? I see my denominator is 3. So we're going to put everything back into increments of 1/3. Okay. So let's go to second window. Okay. And I'm going to say I want to go back to number 1, but I want again uh, to set everything up in 1/3. So I have my 1. I'm going to scoot beside it, and then say alpha window, arrow over to the number 1 of your fraction. Then push enter, put in your 3. Okay, I like to push enter again. That's my habit. And second graph. Okay. So at 1, it's 2, but let's go. See where that gets us right above what we need. There's our 4 over 3, and I'll arrow over, and that gives us our point of inflection. Point of inflection. Okay. All right, what is this really? This is where things kind of turn around, okay? All right, let's see here. 4 over the 3, and then that gives us, this gives us an actual point that we can plot or find on our graph. So let's go back to our graph. Okay, so let's calculate that and kind of look or trace it out. Okay, I'm going to go here And that would be 1 1/3. We're close. So somewhere in here. And if you look at how the graph changes, this is where the point where it's no longer counted as being concave down. Now we're going into concave up. Okay. All right. So that's what all of this is about. And it tells us where our graph is actually changes, gives us a true value. Okay. All right. So let's go to number 5. Given g of x equals 2x to the third minus 9x squared plus 12x minus 3, on which intervals is g of x both decreasing and concave upward? Okay, all right, so what we're going to do is, again, go back to our graph. Okay, second mode, go back to our y equals. Okay, and we can now put that in, but we need to turn off this one. I'm just going to leave it in there and go back to where we have a cleared line, okay? So 2x carrot up to the 3 arrow over minus 9x squared plus 12x, and yes, that's entered correctly, and then minus the 3. Graph it. And there's our graph, okay? We could zoom in a bit, but for now, let's leave it zoomed out. But no, I'm going to zoom in. I say that, and then I change my mind. Let's zoom in just a smidge. Let's see if it'll give us a good zoom in. But I want to make sure that we're zooming in on the area right in there where that curve is happening. That's what we want. Enter. Oh, I did pretty good. That was pretty good. Okay, so what is this telling us? We want it to be decreasing and concave upward. Okay. All right. All right. So let me see here. And it looks like they're telling us there's only one interval. All right. Because notice that our ABCD options only gives us one. Now, probably on an actual test, they would try to mislead you by giving options like for both, for only one, and so on. Okay. All right. So everything is positive. All the values are positive where this curve is happening. So this tells me anything with a negative would be incorrect just by looking at our graph. So I'm saying we have to select option D just because all of our curves are occurring in the first quadrant. Well, that's a dead giveaway, but we still need to check it. Okay, so we still need to know how to do this. And also, I'm seeing that, see where it says decreasing and concave up. Well, that gives us anything, it probably ends around 2, which is correct. And then we know it also kind of changes somewhere here past the 1. So we know everything is occurring between 1 and 2, which option D is telling us it is accurate. Okay. Right. They probably should have done a better job with these ABC choices here. But you know what I've noticed on tests? That sometimes on some of the questions, it might be a more rigorous question, but the answer choices, if you understand the topic, the concept, they're so crazy because you know what you're doing. And in this case, we have a calculator and a graph. It is so obvious. It's ridiculous. I've come across that. You might. I mean, who knows? Okay, so let's do what we need to do here. What do we need to do? We need our second derivative. Okay, so we need y prime equals 6x squared minus, I could do better there, minus 18x plus 12. Now we need the second derivative. Y double prime 12 x minus 18 equals the 0. Remember, you're setting it when you want critical points, you find your derivatives. And for concavity, it's always the second derivative. So then we have 12x equals 18. We divide both sides by 12, and then we deal with this. Okay, I can already see that that will be 3 over 2, but I don't mess with that. Okay, that is going to be one of our critical points. I don't do that. What I do, and I told you, even the simplest, oh, sorry, second mode. Okay. Even the simplest things I put in the calculator while I am testing because I've learned my lesson. You get tired. Okay, let's enter. And 1.5 is 3 over 2. But remember, you can always say math. Number one's highlighted, push enter twice, and that gives you your appropriate fraction. So that tells us that much. Now, for our inflection, for the other one, remember, we need to go to our table. So go to second graph to get your table. And we need we need to put it in halves. Look, everything's in increments of thirds. And we have 3 over 2. So that means we need half. So we go back to second window, go down, and just arrow over where the 3 is, put a 2 in. Okay. And I always like to push enter. It's a habit. Okay, now I go to second graph. And let's see. Oh, and it's right below your number 1 right there. So 3 over 2 equals 3 over 2. Okay. But we need 2. We need to go to number 2. Oh, I should have put in 2 while I was there. I'm going to go back. Put in 2. So we need x. We need both those values, and it would be 1. Okay. Well, that's not helping me much, but I see what it's saying. Okay. So it's saying at 1, that's where it changes. So let me look at this closer here. It's saying we have at 3 over 2, it is 3 over 2, and at half, it's 1. Oh, that's like a coincidence. Okay, okay, I'll buy it. I get it. Okay, so yes, 3 over 2 is 3 over 2 for the x and y values are equal. And then when we go to 2, it really is the value of 1. Okay, so that's where it changes. So then our inflection point, even though that's the intervals, that is also the inflection. No, I'm sorry. Point of inflection. I have things written down here wrong. I'm sorry. The point of inflection is that will be the 3 over 2. And at 2, it is 1. Let's double check that. Let's go back to our graph. Oh, it is. Okay, okay. So you have 2 points of inflection. And it is at 2. Okay. All right, all right. So there's actually 2 of them. We have 2 here, and then the other one goes up. Okay. So then that one is at 2 and 1. Okay. Where everything changes around. It's in between that. Okay. 2 points of inflection. Which intervals? Well, they only wanted the interval, not and that's what they're looking for is because we're talking interval. Oops. Oh my gosh. Let me go back. Okay, there we go. I need they want this, our x values. Okay. All right, this is the last question in this video. Sorry, I got off track just a little bit. I had things written down wrong. I apologize for that. However, we did arrive at some great answers, and now you know what to look for on your calculator. And we zoomed in really great. That worked out perfectly. So this is a pretty good question. Okay. All right. And once again, thank you for sharing and liking our the videos that you like the best so we know how we're doing and sharing with other people. Those numbers are going up. Greatly appreciate it. You guys are awesome. And the subscriptions, thank you so much. You have no idea how much I appreciate that, how everybody appreciates it that's helping and researching. Thank you. Thank you. And happy testing.